like a Hellcat.
Hello, my dear friends. Welcome to Learning Champs. Today, we are about to discuss the topic matter and atoms. So, let's start right away. Anything that occupies space, has mass, and offer resistance is called matter. Everything that we see is made up of either solids, liquids, or gases. A solid has a fixed volume and a definite shape, and liquid has a fixed volume but not a definite shape. It takes the shape of the container. A gas has neither a fixed volume or definite shape. It assumes the volume and shape of the container. An atom is the smallest particle of an element that can take part in a chemical reaction. The size of an atom is indicated by its radius, which is called atomic radius. It is measured in nanometer or angstrom. The hydrogen atom is the smallest atom of all, having an atomic radius 0.037 nanometer or 0.37 angstrom. So let's discuss about the discovery of the atom. It was around 500 BC that an Indian philosopher, Maharishi Kanad, had postulated that matter is divisible. If we go on dividing matter, we can get smaller and smaller particles, and ultimately, the particles obtained may be so small that they cannot be divided further. These individual particles were named as Paramanu. Also, around the same period, Greek philosophers Democritus and Lucifus also put forward the same idea. However, they called the smallest indivisible particles as atoms. In the Greek, it means uncuttable. Now, let's discuss about the Dalton's atomic theory. Dalton put forth this atomic theory of matter in 1808. The various postulates or assumptions of Dalton's atomic theory of mass as follows. Matter consists of small indivisible particles called atoms. All atoms of an element are identical in nature. The atoms of an element are different from the atoms of any other element. A compound is formed by the combination of atoms of two or more elements in simple ratios. Atoms take part in chemical reactions. Atoms can neither be created nor be destroyed. Although this theory has some wrongs, mistakes, but most of this theory is correct. Example, atoms can neither be created nor destroyed. This follows Lavoisier's conservation of mass and energy. Now let's discuss about the structure of an atom. An atom consists of two parts, A nucleus and B extranuclear region or the extranucleus. The nucleus is situated in the center of an atom. All the protons and neutrons are situated in the nucleus. Therefore, the entire mass of an atom is almost concentrated in the nucleus. In the extranuclear region, there are electrons which revolve around the nucleus in orbits of fixed energies. The electrons, protons, and neutrons are also called the fundamental or subatomic particles of the atom. The electron was discovered by J.J. Thomson. The proton was discovered by E. Goldstein. And the neutron was discovered by James Chadwick. The lightest subatomic particle is the electron, while the heaviest is the neutron. The electron is negatively charged, proton positively charged, and neutron is neutral in nature. Generally, the electrons and protons are equal in the atom. Therefore, the atom can be said to be neutral in nature. However, in chemical reactions, these atoms can be changed into positive or negative. In 1913, Moseley introduced an atomic parameter called atomic number. The atomic number of an element is equal to the number of protons in the nucleus of an atom. It can also be said to be the number of electrons in the extranuclear part of the atom. But this case is only present in the neutral atom. The mass number is the sum of number of protons and neutrons present in the atom of an element. It is denoted by the capital A. The mass number is represented either on the left hand side LHS or on the right hand side of the symbol of the element as superscript. All the elements have different numbers of electrons, neutrons, and protons, but the electrons are the only one that can be removed from the atom. These are distributed in various energy shells or energy levels which are given by Bohr. Example KLMN. This distribution of electron in the energy shell is known as electronic configuration. It is based on certain guidelines or rules given by Bohr and Berry. This is known as Bohr-Berry scheme. The maximum number of electrons which can be present in a particular energy shell of an atom is given by 2n square. Here, n is the number of energy shells or energy levels. The outermost energy shell in an atom cannot give more than 8 electrons, even if it has a capacity to take up more electrons according to the first rule. It is not necessary for a given shell to complete itself before another shell starts forming. As a rule, the new shell is formed as soon as the outermost shell acquires 8 electrons. Example, the actual electronic configuration of potassium is 2881. Similarly, for the next element calcium, N shell can have 2 electrons. Therefore, not by showing 2, 8, 10, the electrons are in follows 2, 8, 8, 2. These are the electronic configuration of some elements. To understand why the electronic configuration of an atom is important, we have to look on other cases. A. The electronic configuration of an atom helps us to understand the chemical reactivity of the element. When the outermost shell of an atom is completely filled as per Bohr-Berry scheme, then the element is unreactive. When the outermost shell of an atom is not completely filled according to the Bohr-Berry rule, the element is reactive. An atom can get noble gas electronic configuration in 3 ways: by losing one or more electrons, by gaining one or more electrons, by sharing one or more electrons with other atoms or atom. Thank you for listening to this video. Have a nice day.